Hi, I'm Gautam. Now I'm going to take us on the topic Noiseless Channel Protocol. So before getting into the topic Noiseless Channel Protocol, let's see what we have to see some basic concepts of the network layer. So of the data link layer, one of the basic concept is framing. Framing is the process of dividing a continuous stream of data followed manageable unit called array. Okay. So basically, the data link layer need pack the bits to frame so that each frame is distinguishable from one another. Each frame can be found with some difference. This is one of the main. Some of the most common frame vector stuffing, bit stuffing. Next is flow control. So flow control ensures that the sender does not send the data faster than the receiver can process. The flow control thing that it makes sure that the data that is being received by the receiver has ample amount of. Otherwise, there is a possibility of it getting cracked. Okay. So that is what flow control is basically. And some of the basic methods of flow control: stop, wait, sliding window. Next is error control. So error control ensures that data is transmitted accurately without errors. So basically is that the data that is being transmitted not contain any error, and while receiving by the receiver it should not be having any error. So the techniques that is used: error detection we have a set of, error correction we have a set. So for error detection we have parity bit, checksum, and cyclic redundancy check, which we ARC. Then error correction, for error correction ARQ. Basically ARQ is the automatic repeat request. So under the ARQ, we have three different: stop and wait ARQ, go back in ARQ, selective repeat ARQ. So these are the techniques that is involved while correcting the errors that could possibly occur while transmission. Okay, so now let's get into the topic. So what is a protocol? So basically, a protocol is a set of rules that govern communication between devices and the, like, simple protocols is that. So we have the framing, flow control, error control. Now we have to, like, the data link layer has to combine all these things together, achieve the delivery of data from one node to the other. Okay. So for that, like for the delivery of data from one node to the other, must it must follow a certain set of rules, and those rules without any character specific, like without any language specific, it is being said as protocol. So protocols define how data is being formatted, how the data is being transmitted, how the errors are being handled, and how devices are communicated. So protocol classification is mainly classified into two: noisy channel and for noiseless channel. For noiseless channel, we have simplest and stop and wait protocol. Okay, we have these two protocols, and this is the two protocols which we'll be covering in this seminar. And then for noisy channel, we have stop and wait ARQ, go back in ARQ, and selective repeat ARQ. Why we are covering noiseless channel? Noiseless channel is easier to handle, and Once the noiseless channel is covered, then next we'll be into the noiseless channel is a communication channel where no data is lost, no data is being corrupted, and frames arrive in the same order in which they are being reversed. Okay, so like is basically a channel that is completely perfect. The protocols are simpler and is easier to work with when compared to noisy channels where there will be a set of parameters that affects the communication. Whereas in a noiseless channel, it is completely perfect so that we can neglect all those external factors. So the main two protocols of a noiseless channel is it is simplest protocol and stop and wait protocol. So these two protocols control how the frames that is being moved from the sender and the receiver. It completely shows how the data or like how the frames are being moved or like transmitted from the sender to the so simplest protocol. So this is a simplest protocol. The name itself it is the most easiest and simpler protocol. Used when the receiver can process the frames immediately. Like the receiver has the capability to accept the frames immediately without sending any up. So the sender continuously sends frames and the receiver continuously accepts. So no acknowledgement is required. This protocol ignore acknowledgements. The receiver is always ready to receive the message or the frames that is being sent by the sender. So this is a diagrammatic representation of how it goes. So like the sender gets the data and then the network layer fetches it from the sender and then through the data link layer it goes and then through the physical layer the sender and then the frames go and then again the physical layer is responsible for receiving the data that is being sent and then again with the help of data link layer it is being the receiver. Receivers reads the message. So so this is just a diagram how it works. So sender A. So basically sender sends the frame and receiver B is also ready to accept it. And again he sends another frame. And in the meanwhile receiver B accepts or receives it. So it does not carry or like it does not worry about whether the receiver has received it or not. It will continuously send and most of the cases the receiver will accept it. And this is the efficient way. It is the most simplest and effective way so that the time is saved as much. Next is stop and wait. So in this protocol, sender sends only one frame at a time. Sends only one frame at a time. Sender waits until the receiver processes it, and after processing, the sender sends the next frame. So this prevents the receiver from being overloaded. So in the previous thing, there is a possibility of for the receiver to be loaded with too many frames. Like for example, if it might not have been processed, it might not have processed the first frame, but by the time it might have got another four frame. Like in order to prevent that, we will be using this stop and wait. So here the sender sends only one frame at a time, and sender waits until the receiver processes it. So and then the processing only the next the sender sends the next. Okay, so here basically yeah. So basically, the thing is that once the receiver has processed the data, it will send an acknowledgement to the sender. So once Sender receives that acknowledgement. Only after that it will process the, then will send the next. So here is that the sender will be like, it's the data from the sender in the network. Okay. Through the data link layer, this is the frame is being formed. Frames, that frame is being conveyed, and that is being received by the physical, is being received by the, then again with the help of a link layer in the normal message, then it is received by the receiver. Okay. So once this thing is done, it will send a acknowledgement frame. Acknowledgement frame will be transmitted from the receiver to receiver through the data link layer, and then again be received from the sender's physical host. This way to stop read protocol to sender A, basically A and again the sender A and the receiver B. So the sender receives, I mean sends the frame first, and then upon arrival of the frame it will give pass the acknowledgement. Once the acknowledgement is received, only after then the next frame is being sent. If we did not receive an acknowledgement, it won't send the, it will wait as long as the acknowledgement is being received by the, like acknowledgement is received by the sender by the, which is being transmitted by the receiver. So only after then it will start to send the next frame. And because of this, obviously they won't be overloaded. Like this might be time consuming, that is one factor, but taking the time out of the equation, so it's basically time, I mean the is efficient way, like we will, cannot, like the receiver will not be overloaded with what is being sent by the sender A. And at the same time, sender can wait for some time for the next frame to be sent. So this is a much more active way than the previously concluded stop and wait. I mean previously concluded simplest. Yeah. So this is the most preferred one because of the effectiveness, efficiency. So so in the now, like we will be having a question of like, what does a noisy channel do? Basically, so in spite of having the stop and wait protocol, which gives us an idea of how the flow works, or like how the flow control is. So it's, this is a like I mean noiseless channel. Like there are a set of protocols which is being there in the noisy channel, right? Which is the stop wait ARQ, which is ARQ is nothing but automatic repeat request. Likewise in stop, like likewise stop and wait, we have go back and automatic repeat request, and then selective repeat automatic repeat request. So these three protocols will be are further included in noisy channels, and these protocols are comparatively difficult than the ones that is being discussed in this thing. That has to be kept in our mind is that while handling with noisy channels, it is to be kept in our mind that it will be dealt with frame, or it will be dealt with data which contains error. It is not something as like as we have discussed in this topic. It will contain error. This topic will not, as we have clearly mentioned, perfect uh, data. That in that thing it won't be perfect. It will consist of certain errors, and those errors will be rectified by the mentioned. Yeah. So, but that's not, we will not be discussing in this video. That this video is purely for noiseless channels protocol. Hope clear. Thank you.